Lesson 2 for this chapter is trig ratios for angles from 0 to 360 degrees. So traditionally, if we are calculating the Pythagoras theorem, it's the two sides squared, which we can label a and b, so a squared plus b squared equals c squared, where c is the longest side or the hypotenuse of my triangle. If we are looking in terms of trig and we map this onto a coordinate grid and we put our triangle there, the two legs of the triangle, instead of being a's and b's, are now x's and y's, and that hypotenuse matches to the radius of the circle. So I can change my Pythagoras theorem to become x squared plus y squared equals r squared. The point xy lies on the terminal arm of this rotational angle, and the distance from the origin to this point is the radius. So if we look at class example number 1, we are asked to sketch the rotation angle in standard position and then calculate the exact distance from the origin to the given point. Where it's appropriate, write the answer in simplest mixed radical form. So if we look at the point -5 and 12, which quadrant would I be in? 2. So when I go to sketch this, I can sketch my coordinates or my quadrant plane maximizing quadrant 2. And then I can label my point P. And then if I label my triangle, what would be the length of the horizontal leg of my triangle? What would be this length? -5. And what would be the vertical leg? 12. So then my radius, if I use my Pythagoras theorem, I'd get -5 squared plus 12 squared. What is -5 squared? 1.5. And what is 12 squared? 144. And what's 144 plus 25? So then r would equal the square root of 169. Is 169 a perfect square number? Yeah. So what is its square root? 13. Okay. My radius will always be a positive value. It will never be a negative answer, because there's no way of square rooting this and getting a negative. Not to mention we're talking about distance, so my distance is going to be measured always as a positive value. If I have the point Q, which is at -2 and -6, which quadrant would I be in? The fourth quadrant. Right? Third quadrant. It's a Monday morning. So if I'm in the third quadrant and I have my point Q, it would be better if my line was a little bit straighter. And I create my triangle. What's the horizontal leg of my triangle? And what's the vertical leg of my triangle? So then my radius again, my r squared, would be x squared plus y squared. And -2 squared is? And -6 squared? So 36 and 4 is 40. So then my radius would be the square root of 40. Does 40 contain a perfect square? Four times what? And what's the square root of 4? So the radius in mixed radical form would be 2 root 10. next page we go through our trig functions. This is from last year. If I have an angle theta, in relation to that angle, we call this the opposite side. This one is the adjacent side, adjacent being next to, and then my hypotenuse is always the longest side. So in terms of those values, my sine ratio is equal to what? What was my acronym that I used? So then opposite over hypotenuse for SO. What would cosine be? And what is tan? So in the next part, if I took that triangle and instead of talking about opposite sides and adjacent sides and a hypotenuse, again I went back to my x, r, and y, my sine ratio, which above was the opposite over the hypotenuse, would become what?
Y over x.
Y over hypotenuse. What's the hypotenuse? R. So sine would become y over r. What would cos become?
X over r.
And then what would tan become?
Y over x.
You don't need to memorize these formulas. You know what SOHCAHTOA is. You can sketch this out and you can very easily find these without having to memorize them. And we'll prove that by doing the last example before you work on some questions. The point 15 and 8 lies on the terminal arm of an angle theta as shown. That's what this point is. Calculate the value of r and then determine the exact value of the primary trig ratios. So if this is my point 15 and 8, what does the x value correspond to? And what is the y value? So then I'll do r squared over here. R squared would equal 15 squared plus 8 squared. What's 15 squared? 225. What's 8 squared?
64.
And what is the sum of 225 and 64?
289.
So then r would equal the square root of 289. Check to see if 289 is a perfect square. Can I take the square root of it? 17. So then my r value is 17. So now if I look at my three trig ratios, I have sine. So sine theta, what was my ratio for sine theta? Y over r, opposite over hypotenuse. So y is 8, r is 17. Cos theta would be equal to what? And tan theta will equal in terms of fractions, if I look at cos and sine, what type of fraction will I always get? Or first of all, before we say what type, what are the two types of fractions I can have? Proper and an improper fraction. What's a proper fraction? So it's less than one whole. And an improper fraction is when I change into a mixed fraction or a mixed number. Okay? So what kind of fractions will I always get for cos and sine? they're always going to be proper because they're always over r, which was my hypotenuse, which is my longest side. So my sine and my cosine ratios will always be less than 1. They're always going to be less than 1 whole. My tan ratio could be more than 1. Okay? Because even if this was from angle theta. Even if I went and I made this my angle theta, my sine would be 15 over 17. Cos would be 8 over 17. And this time tan would be 15 over 8. So tan can be bigger than 1. Sine and cos can't. So what I want you to work on is questions 1A, 2A, and 5. When you are done those questions, I then want you to start on the investigating the part 1, 2, 3, and 4 on the following pages. Okay? So if we look at the investigation, we're looking at trig ratios for angles that are going to be greater than 90 degrees, between 90 degrees and 360 degrees. So we're going to start off with an angle in standard position in the first quadrant. If the point of that angle is at 1 and root 3, it says show that the value of theta is equal to 60 degrees. So if point P is 1 and root 3, that means that root 3 is my vertical and 1 is my horizontal. How can I show that theta was equal to 60 degrees? So tan theta equals opposite over adjacent. How do I get that to give me 60 degrees?
You do tan inverse.
I go, oh, sorry, let's put the theta in front. Theta equals tan inverse root 3 divided by 1, or just root 3, and then I should get 60 degrees. If I don't get 60 degrees, what should I check?
Mode your calculators in.
Check the mode that your calculator's in. What mode should you be in? Degree mode. So if you're not getting 60 degrees, it's because you're not in degree mode. So make sure your calculator's in degree mode. So press the mode button, and then if it's not in degree mode, you have to go down to it, highlight it, and press enter. If your calculator was reset, it will default to radian mode. You have to physically change it to degree. That's not the default setting. If I calculate the value of r, so r would equal x squared plus y squared. So 1 squared is 1. What is root 3 squared? 3. 1 plus 3 is, so r squared equals 4, which then means that r would equal 2. So it says complete the following using that x is equal to 1, y is equal to root 3, and r is equal to 2. So y over r would be root 3 over 2, 1/2, and root 3 over 1. So that's in the first quadrant. Then we move it into the second quadrant. If I take that rotational angle that was at 1 and root 3, and I reflect it across the y-axis, what would the new coordinates become? -1 and root 3. So it's only the x value that would become negative. The rotational angle, or sorry, reference angle first. If I create this triangle here, this triangle here is going to be the same as the triangle I drew above. And what was theta in that triangle? 60 degrees. So if this is the exact same triangle, my reference angle, which is the angle created between the terminal arm and the x-axis, would be 60 degrees, and my rotational angle would then be 120, 180 minus the 60. If I label the parts of my triangle, I have that this is -1, this is √3, and my r is still going to be 2. Because it's the exact same triangle that I drew in the first quadrant, the exception being that x is -1. So now when I look at my trig functions, this sine 120 degrees refers to the rotation angle, but I'm still looking at the triangle, that reference angle that was created. So in that reference triangle, y over r would be √3/2. Cos would be a -1/2, and tan would be √3/-1, or simply -√3. So if you grab your calculator right now, so we make sure that we're in degree mode. If I type in sine 60 degrees, I get this 0.8660 blah, 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 blah. If I go √3 divided by 2, I get the same answer. Because that's what that ratio was √3 divided by 2. If I press sine 120, I get the same answer. If I try cos 60 degrees, there's my 0.5. Cos 120 degrees, my -0.5. And I can do the same thing with tan. So let's look at part 3. If I took that triangle, my original triangle that I drew over here, and I now reflect that point in the y-axis and then in the x-axis, what would be my new points? So remember, my original point was 1 and √3, and then when I moved it into this quadrant, it became -1 and √3. So in this quadrant, it would be so -1 and -√3. So -1, -√3. What's the radius going to be? 2 again. It's not going to change. It's the exact same triangle. If it's the exact same triangle, what's the reference angle of that triangle? 60 degrees. What's the rotational angle? 240 degrees. So again, if I go back to my trig function, sine is opposite over hypotenuse. Opposite over hypotenuse would give me -√3/2. Cosine, -1/2. And with tan, I get -√3/-1. The two negatives give me a positive answer. And I get positive √3. And I can check this out with my calculator. If I go sine 240, I get that -0.8660. Cos 240 gives me -1/2, or -0.5. Tan 240 gives me 1.73 something. 240 gives me the same thing as tan 60. And almost the same thing as tan 120, just it's a negative in 120. So now we move into the last quadrant. So if I took that triangle that was up here and I reflected it down here, what would the points be?
1 and negative.
Thank you. Again, I'm going to get this reference angle of how many degrees?
60.
And then the rotational angle would be
300.
300. Good. So if I label this out, I've got 1 negative root 3. Radius is still 2 because it's this exact same triangle I've used all along. What's sine?
Negative root 3 over 2.
Thank you. What's cos? And what is tan? Or just negative root 3. So the observations to make is that the trig ratios of the angles between 90 and 360 degrees are either the trig ratios of the reference angle or the negative trig ratio of the reference angle. In other words, in that first quadrant, my trig ratio for cos was 1/2. In the fourth quadrant, it's the same thing. In the first quadrant, my trig ratio was root 3 over 2. In the fourth quadrant, it's a negative. It's the exact same ratio, it's just the negative of that ratio. So the question that happens is, how do I know what sign should be which? So we're going to fill this chart in. I'm going to start it in quadrant 1, and then I'm going to get you to finish it. So cos x over r and tan y over x. So in the first quadrant, what can you tell me about the value, the sign of x and r? So r is positive, x is positive. So if I have a positive value over a positive value, I will get a positive answer. Y is positive and x is positive. I get a positive answer. If I go into the second quadrant, what can you tell me about the sign of x in the second quadrant? And the sign of y would be positive. So then sine, cos, and tan. So sine is a positive value over a positive value. Remember I said before my radius will always be positive. So in the second quadrant, sine's positive. Cos is a negative value over a positive, which would equal a negative answer, or a negative value. And then tan is a positive value over a negative value, which would equal a negative value. So I want you to finish quadrants 3 and 4 the same way. So if you look at the chart, I've completed it in for quadrants 3 and 4. In quadrants 3, both x and y are negative, which means my sine and my cos were negative and tan was positive. In quadrant 4, y is my negative value, which meant that sine and tan were negative, but cos remained positive. So using those results, let's fill in the sentences. So sine is positive in which quadrants? 1 and 2. Which then means if I go down to here, sine would be negative in 3 and 4. When was cos positive? 1 and 4, which means it's negative in And then tan was positive in, which means it's negative in. That gives us the CAST rule. In the CAST rule, all of my trig ratios were positive in quadrant 1. Sine was positive in 2, tan in 3, and cos in 4. So CAST, you have to start in the bottom corner, C-A-S-T. Or if I start here, I can do add sugar to coffee for my acronyms. Just to repeat, this CAST rule, all it is it's a short way or an abbreviated way to remember which trig function is positive in which quadrant, so that I don't have to memorize all of this. If I can use the CAST rule, I can then look at everything as being a reference angle, and then I just have to switch it around depending what quadrant I'm in. So if I use a reference angle where in the first quadrant sine is positive, but I've now moved to the third quadrant, my sine ratio will be negative because the only one that's positive down here is tan. If my reference angle puts me in the fourth quadrant, only cosine will be positive. Sine and tan would be negative. And they'll be negative because they both have that negative y value. So determine without using technology whether the given trig ratios are positive or negative. So sine 340. What quadrant am I in? In the fourth quadrant, what sign is sine? Negative. So sine of a 340-degree angle is going to be a negative value. 227 degrees, what quadrant am I in? Quadrant 3. And what is the value of tan in quadrant 3? Positive. Okay, do the same thing for the next 4. Figure out the quadrant and then figure out using the CAST rule. 88 degrees. What quadrant am I in? Quadrant 1. And what is the sign in quadrant 1? Positive. 235 degrees puts me in quadrant. And what is cos in quadrant 3? 308 degrees puts me in quadrant. And what is the sign of cos in quadrant 4? And 123 degrees is in quadrant. And what is the sign of tan in quadrant 2? So the trig ratio for any angle is either the trig ratio of the reference angle or the negative trig ratio of the reference angle. So we can do this using the following procedure. Determine the sign of the ratio. Is it positive or negative? And you do that by determining the quadrant that you're in. Determine what the measurement of the reference angle is, and then combine the two. So for example, if I have cos of a 260-degree angle, 260 degrees puts me in quadrant 3. So I'm in quadrant 3. Cos in quadrant 3 is negative. The reference angle, I get the reference angle by taking 260 degrees and subtracting 180 degrees because I'm in the third quadrant. That gives me 80 degrees left over. So then I put it together by saying that cos 260 is equal to negative cos 80. Negative cos 80. So the negative comes from quadrant 3. The 80 comes from the reference angle. So we're going to do this last set of examples. Rewrite as the same trig function of an acute angle. Remember, an acute angle has to be less than 90 degrees. So if I'm looking at 140 degrees, which quadrant am I in? Quadrant 2. And I use my cast rule. There's my cast rule. In quadrant 2, sine is what? Positive. In my cast rule, it's the positive values that are listed. A for all, sine, tan, and cos. So in quadrant 2, sine is positive. What's my reference angle in quadrant 2? So how do I find the reference angle?
180 minus 140.
And what is 180 minus 140? So now I have my sine and my reference angle. So I can say that sine 140 degrees would be equal to sine of 40 degrees. So I'll do one more, and then I'm going to let you do the next 4 on your own first. 323 degrees puts me in which quadrant? Quadrant 4. And in quadrant 4, what is the value of tan? It's going to be negative. How do I find the reference angle when I'm in quadrant 4?
360 minus 323.
So 360 minus 323, which equals?
37.
So I can say that tan of a 323 degree angle will equal the negative of a tan 37 degree angle. So try a similar process for the next 4. Let's finish this up. 4C, which quadrant am I in?
2.
So quadrant 2, and in quadrant 2, cos is,
Negative
and what's my reference angle?
15.
How did you get 15?
180 minus 165.
So then I can say cos 165 is equal to,
Negative cos.
good. Okay, sine 287, what quadrant am I in? Quadrant 4. And in quadrant 4, sine will be,
Negative.
how do I find the reference angle?
360 minus 27.
Which equals,
73.
so then sine 287 would equal,
Negative sine.
308 degrees puts me in quadrant 4. And what is cos in quadrant 4? Positive. What's my reference angle?
52.
So 360 minus 308. So cos 308 equals,
Cos 52.
and finally tan 199 degrees. What quadrant am I in?
3.
And what is tan in quadrant 3? What's my reference angle?
199
Which equals,
minus 19.
so tan 199 degrees would equal,
Tan 19.
okay. The next part just looks at the patterns and the trig ratios. I'm not going to ask you to even really look at this. If you combine the reference angles and the cast rule, you don't need to look at this. Okay? So these are the questions for you to work on, and then we can look at lesson number 3 tomorrow.